In this video, we're going to talk about something near and dear to my heart, lake effect snow. So from the home page, let's start with a general overview, go with the GFS. And first, I guess we should start off with a more large-scale view of things, get you an idea of what this trough is doing, kind of in the Great Lakes area. So I'll zoom about there, and let's take the 850 temperature. Then we'll go ahead and loop that. This whole event's pretty short term, so we'll only loop out to, we'll make it 4 days. Grab that. Okay. You can see it's November 11 today, so it's quite an impressive Arctic air mass for this time of year coming down. But you can see it modifies rapidly as it goes over the Great Lakes and into the Northeast. Very typical, and then we get into a warm air advection pattern over the Great Lakes already by the 13th. So this is kind of the general synoptic setup for this event. So as we watch this loop a couple times, you can see initially you have pretty good cyclonic curvature over the lakes. So we're behind this low. It's over there by Lake Ontario. But as we go a few more frames, you can see shortwave ridging moving in already. So we have anticyclonic turning of the flow, and a lot of times that comes with subsidence and tends to weaken the lake effect process. Another thing to note is the flow is pretty northwesterly in this event, so Lake Superior, Lake Michigan, Lake Huron are the main players, and the other lakes, if you're downwind of Huron, you get preconditioning, then you may get a lot of snow downwind of Erie, but otherwise you're not going to be able to rely on the short fetch off these lakes for this event a whole lot. Ontario, sometimes this northwest flow can give you pretty good snow down here. So okay, that's the general overview. Now we can start going into the details. I'll jump back out of loop mode. And I'm going to focus mostly on southern Michigan. Of course, that's where I grew up, so there's a bias towards that area. So I'll zoom in. I didn't quite get what I wanted there, so let's go like this. And then let's look at when this event really starts to set in here. Well, we can start at 0Z and see what we're looking at. Okay, so again, pretty northerly flow, so you've got a long fetch here. And already minus 12 to minus 18 over the lake at 850 millibars. Maybe if we look at the surface temp, we get a feel for the lake temperatures. Now this is the 2 meter air temperature, so the lake is actually quite a bit warmer than this. But so lake's probably still 45 Fahrenheit here on the eastern side. So there's tons of instability there. In fact, let's do a quick sounding and get a feel for where the dendritic growth zone is, the DGZ. Grab that here and can see early on it's up kind of 850 to 800 millibars. So 850 is not a bad choice here when looking at the wind flow, because we're interested in where these snow bands are going to develop. And the strongest snow bands are going to be in this DGZ. You can see pretty uniform north-northwest flow, from there on down through the boundary layer. Alright, so let's look at temperature 850. And we can kind of step through this a little bit. You can see strong cold air advection coming in. Also cyclonic curvature that I mentioned before, so we would expect some pretty good lift in this area. And this is kind of the time frame tonight when I think the heaviest snow will probably occur. Got a long fetch across a good part of Lake Michigan. Tend to get convergence on the cyclonic side of the lakes in these events, so that's the east side in this case. Remember, our low is off to the east. So let's move on to 9Z, kind of like peak intensity of the event. You can see we have minus 20 at 850 coming over the lake at this point. So now we can probably start doing some sounding analysis. So maybe we can even zoom in a little bit more again. Go a little further south. There we go. Okay, so with this fetch, this flow, we would expect a band kind of to form in this area. And so actually we can look more directly at that. So if we just look at simulated reflectivity, now it's low resolution from the global model, but it still gives us an idea. So it's got this snow band kind of sitting up here in Allegan and Van Buren counties. So if we look at a skew T through the center of that band, we can get a feel about the thermodynamic environment. Okay, and the things to look at here are, first of all, our inversion height is way up at 700 millibars. So the shallow convective lake effect process has a pretty deep layer to work with here. You know, clouds that are forming in the boundary layer are going to be able to lift all the way up above 700 millibars before they hit that inversion top. We also can look at the amount of lift. And see this purple line here, this is the vertical velocity versus height. And the scale here on the bottom, it shows the negative numbers mean that you have rising motion. So you can see we have strong rising air in that DGZ, so that's going to generate large snowflakes. So we already know that our snow ratio is going to be more than 10 to 1, probably a lot more than 10 to 1, given this kind of profile. Okay. Jump back out of this and kind of see how this evolves as we go forward in time. You can see the flow is becoming a little more westerly. In fact, we could go ahead and overlay winds. And at this point, I'm going to look at 900 millibars because that air mass is getting colder and our DGZ is getting lower, so closer to the ground. So I'll put those winds on there. You can kind of see that band is following that 900 millibar flow pretty closely at this point. Moving on to the middle of the afternoon tomorrow, as that ridge builds in, you can see our reflectivity weakening, the flow going around to the west, very typical progression as warm air advection starts to kick in. And by tomorrow evening, most of the snow is backed off in the GFS at least. So we're out to 36 hours now. What we can do is see what the precipitation forecast. Let's look at 24-hour precip at 36 hours. There's a synoptic event going through right now, so we want to kind of let that get out of there before we look at just the pure lake effect event. If we look at that, you can kind of see Van Buren County is the bullseye here, with maybe about a half an inch of liquid equivalent there. So looking again at the 850 temperatures tomorrow afternoon, what we can see is as that ridge builds in, the flow does come back around to the west, but you tend to lower that inversion height when you get that ridging moving in, and we can confirm that with a sounding here in this location. What we'll see is before, remember, that inversion was up at 700, now it's coming down. It's still above 850, and there's still some weak lift in the DGZ, so you're still going to have snow here, and you could still even have accumulating snow with this profile, but definitely not the intensities like we were seeing before. Alright, at this point, let's jump over to the more high resolution models. We'll look at the HRRR. So we'll grab the 12Z cycle, and then we'll start out at 6Z tonight, which is an 18-hour forecast from 12Z. And we can look at our 850 pattern. You can see it's kind of interesting. Small scale wave-like features over the lake. Really, this is probably just convergence being forced into this band that's going to form on the low pressure side of Lake Michigan. So what we can do now is look at simulated reflectivity, see where that band is set up, and you can see sure enough there's that strong single band. And go ahead and put a loop of this on. Take a minute to generate those frames. You can see at the beginning, here's our synoptic event that's going on now. And already, even during the synoptic event, you can see this north-northeast lake effect band that's set up and heading into the Chicago area. But as the flow comes around, that band moves over to the Michigan side, sets up there. And you can see it holds pretty steady along the lakeshore there for several hours. And then that ridge starts to move in tomorrow. So let's go back and kind of look at some of these interesting times. So if we look here, we know we're just going to have intense lift in this band here in Berrien County. So let's that's a 17-hour forecast, so let's jump out to hour 17, and then let's put a sounding in that snow band and see what that lift and temperature profile looks like. Yeah, you can see very strong vertical velocity right in the heart of the DGZ, inversion height up at 700 millibars. So this is just going to be really intense snow in this band. Wouldn't surprise me at all to see 2, 3, or even more inches an hour type snowfall rates out of that. Maybe even some thunder and lightning too with that kind of lift. Another way to look at it, if you want, is vertical velocity. Can be interesting. So put that up for 850 millibars, and you can see, sure enough, that of course lines up with where that snow band is. Step through a couple times here. You just see intense lift in that shore parallel band. Be some really heavy snow, very dangerous driving conditions there, and this is Interstate 94. You see this because westbound traffic will be in, clear skies, no snow at all, and then they'll drive into Berrien County and come into 3-inch-an-hour snowfall rates. You see a lot of traffic pileups, crashes in this area when this happens. Okay, so another thing we can look at then is the precipitation for this event. So let's do like we did with the GFS. We'll go out to 36 hours and 24-hour precip. You can see that dominant shore parallel band, and I notice that HRRR has this secondary band that forms later when the flow starts to come around more to the west. Pretty skeptical of that, although it is November and the lake temps are still in the 40s out here, so even with the lowering inversion height, you still might get a pretty strong band tomorrow afternoon in this area, but I'd be pretty skeptical of these amounts here. So one thing that can be interesting to look at is how the snow algorithm is doing with the ratios, because we know we have intense lift in the DGZ, so we would expect a snowfall ratio much higher than 10-to-1 in this case. So just so you can see this, in here we have about an inch of liquid equivalent in that band. So if we look at the actual snow that the algorithm comes up with, and if you're interested in reading about how this algorithm works, you can click on any of these question marks here. It gives an explanation. But we see an inch of liquid converting over to 18 to 20 inches of snow, which is, I think much more realistic. It's more like a 18 to 20 inch ratio, 18 to 20 to 1 ratio. So certainly possible that places here in Berrien County could see a quick 1 to 2 feet of snow here tonight. If we zoom out, we can kind of see what the rest of the Great Lakes are up to. Of course, we have this synoptic event kind of making the analysis a little more complicated in the eastern lakes. But you can see north-northwest favored areas, quite a bit of snow here in the HRRR. See downwind of Lake Superior, another hot spot. Of course, here you have a wider fetch. It's more of a perpendicular flow across the lake, so you don't quite get the single dominant band like you do downwind of Lake Michigan down here. But you still probably do see some very intense lift at times in that band. So we can go take a look at that real quickly. So set the forecast hour back to tonight, and then vertical velocity 850 millibar. And you can see, yes, again, similar to what we saw off Lake Michigan, although, and this is an interesting case, looks like we have multiple bands initially that kind of merge into one band. Get some pretty crazy snowfall rates when you get snow band merger like this. Do a quick sounding in there. And you can see, yes, just extreme lift in that band. Now, this lift does kind of peak a little bit above the DGZ. It's so cold up there in the northern lakes that the DGZ is getting close to the ground. But still, you have strong lift here in the DGZ, so you're going to get large flakes, maybe some mixture of flake sizes here, but very high, very intense snowfall rates. Just a quick look at the precipitation, snowfall up here. You can see, yeah, intense lake effect snow in the Great Lakes tonight and tomorrow. kind of a short-lived event. It's only going to be 24 hours or so, but kind of a typical north-northwest flow lake effect event, the Great Lakes.